This is the video for Unit 3, Lesson 4, Writing Ionic Formulas with Polyatomic Ions, and the objective is that students will be able to write ionic formulas containing polyatomic ions. The only vocabulary for this lesson is, in fact, polyatomic ion. So the first thing we're going to do is break down this word, polyatomic ion. Poly, this prefix means many. Atomic sure sounds a lot like atoms, and ion means it has a charge. Okay? We can actually say here many atoms form a compound with a charge. And the other piece that you need to know is it is technically a covalent compound with a charge. So go ahead and pause me and write that down, please. And we're going to take a look at some examples here. These are on the back of your periodic table. You do not have to memorize them. They are 6 different polyatomic ions, and there are many, many more, but we only work with these ones. If you want to work with many, many more, take AP Chemistry. And so here you have the ion name. They have their own names, and then here's the formula. The confusing part is that they call it an ionic formula, and you should be confused because I just told you it was covalently bonded. So the reason they actually call it ionic is because of the charge, okay? But if you look, nitrogen and hydrogen are both nonmetals. Nonmetal, 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 they're all nonmetals, which we know form covalent bonds. Again, the ionic comes from the charge. So what I need you to be able to do is differentiate between the compound and its charge, all right? So take a look here. For the compound of ammonium, or the ion, you have NH4, which is the compound, and its charge is 1+. For carbonate, the compound is CO3, and the overall charge is 2-. Okay, so see how I'm training my eyes to read the compound and then the charge? Go ahead and see if you can figure out the hydroxide. What's the compound? If you said OH, you're correct. And what's the charge? 1-. Okay? So if you are a very good student, you're going to pause me so I don't give you all the answers right away. And the last one is sulfate, SO4. Its charge is 2-. Notice how I am drawing the 4 as a subscript because that tells me how many oxygen atoms I have, and the 2- is a superscript. Don't mess those up. They mean something very different. Here's the last thing that I want you to keep in mind. Whenever you write a polyatomic ion, you never, ever, ever get rid of the subscript, okay? Alright, so by that I mean, if it says NH4, you never change the compound. See the stuff in blue? It always, always, always has to stay like that, okay? Remember that. So we are going to learn how to read compounds. I want you to be able to look at these 3 different compounds and tell me what would they look like at the molecular level. Okay, that's our next step in being able to write polyatomic ionic formulas. Okay, so I want you to think about how many calcium atoms I have in this red compound, how many oxygen atoms, and how many hydrogen atoms. Okay, well, I have 1 calcium, 1 oxygen, and 1 hydrogen, right? There's no subscripts, and so I assume those are all 1. Easy enough. Let's look at the one in blue. There's clearly some parentheses here, so we want to figure out what do those parentheses mean. All right, so there's still only 1 calcium. I'm literally looking right here, and there's no number there, so I assume it's 1. That tells me I have 1 calcium. But what does the rest of it mean? Listen carefully. This 2 means that I have 2 of whatever's inside the parentheses. What's inside the parentheses we just learned is hydroxide, so I have 2 hydroxides. So visualize what that means. 1 hydroxide would be 1 O and 1 H. but I have 2 of them, so it would be another set. And that would be CaOH2. Let's take a look at the black compound here. I still have 1 calcium, but now what does the rest of it mean? It means I have 2, look outside the parentheses first, I have 2 of whatever's in here. So what do I have in there? How many O's do I have? If you said 1, good job. And then how many H's do I have inside the parentheses? I have 2. If you didn't realize, that is just H2O, which is water. So that's 1 water, but I have 2 of them. So I need to draw another one. O, H, 2. Okay, so look at the red, the blue, and the black, and look how important it is when you add parentheses or when you add numbers inside of the parentheses. Alright, so we are going to test to see if you got out of the last slide what you were supposed to get out of it. I am going to ask you how many atoms of each element do you have in this compound. So you should stop, try to draw the compound, and then count up the atoms and see if you get the same answers as me. Now, if you are somebody who just gets the pattern and you do not need to draw, then you can go ahead and just count, okay? But if you're having a hard time, draw it out and visualize, okay? So pause me and try. Okay, I'm going to draw it out now, and if you didn't pause me, you are a cheater. Okay, so I have, again, train your eyes. I always look at the thing in parentheses first. The compound, sorry, not thing, compound. Okay, so I have, within that compound, I have 1 N and 4 H's. 1, 2, 3, 4. But this little 2 here tells me I have 2 of those. So just go ahead and draw it all over again. N, H, oops, those should be touching, H, H. And I don't care how you draw it. It could be a big blob. They have to be touching though, it's somewhere. So that's my NH42. And now I have an S. I just have 1 S, right? And then I have 4 more O's. Look at this crazy thing. That's what that means. It's a blob. Now it's actually structured very differently, but for right now that's fine. Okay? So now go ahead and count them all up. Okay? How many N's do I have? 2. How many H's? 8. How many S's? 1. And how many O's? 4. Okay, give yourself a little pat on the back if you got that. And now we're going to talk about the shortcut. I hate teaching shortcuts first because I hate when people try to remember patterns instead of actually thinking about the chemistry. If you just try to memorize the pattern instead of understanding how to draw it, you're going to be in trouble. Okay? So the pattern is multiplication. Okay, you might have already picked up on that, but there is a secret 1 here, right? I'm even going to draw it so you can see it. There's a 1 there even though we don't draw it. 2 times 1 is 2. 2 times 4 is 8. Okay? And now we don't need to multiply because we just count. There's no parentheses. 1 S, 4 O's. Alright? So that's the trick. It makes sense if you think about the drawing. I have 2 sets of this stuff, so I'm multiplying it by 2, right? So I'm going to do a few examples for you where I'm writing compounds that contain polyatomic ions. The trick to getting this is that you write down the example yourself as you're taking notes. Okay, so you can listen once, rewind, and then take down the notes. Please pause while you're taking notes so that you don't miss something important that I'm saying. Okay, so let's say I have a polyatomic ion between aluminum and hydroxide. Okay, this is our polyatomic ion, hydroxide. I know right away it's polyatomic because there's more than 1 element. And this is a monotonic element. There's just 1 Al, okay? The question is, in what ratio do these two need to bond in order to make a neutral compound? Okay, do I need one Al and one of these? Do I need two of these and one of these? The thing to keep in mind is the compound must be neutral. So when we wrote ionic compounds before, what you learned is to think about the valence electrons here, the valence electrons here, and move them around until you get full octets. The issue is that we can't do that with this because we don't know valence electrons for OH. It's a compound. So you can't really talk about valence electrons like we used to. So our guiding thought is, how many of each do I need to make a neutral compound? All right? So the first thing I need to do is think about the charge of aluminum. You should be able to very quickly tell me the charge of aluminum is 3 plus, and from the periodic table, you also should be able to tell me that the charge of the hydroxide is 1 minus. That's literally on the back of your periodic table. Go look at it, find it. I didn't make it up. It's right there. So how many aluminums do I need and how many hydroxides do I need to be neutral? Right now, it is not neutral. If I were to take one aluminum and try to bond it to one hydroxide, okay, that would not be neutral because this is 3 plus and this is 1 minus. 3 plus does not balance out 1 minus. I need 3 minus to balance out 3 plus. Okay, and I just want to sort of highlight, because this confuses people, to simplify my drawing, I just represent the ion as a circle. I don't draw it as like an individual O and an individual H. It's just confusing. I just draw it as like a compound, as one circle. Okay? So basically what needs to happen is that if I keep adding OHs, okay, now I have 2 minus and 3 plus. That still doesn't balance, so what I need to do is add another hydroxide. And again, I'm color coding here so you can see the charges. Alright? So I have 3 plus, and then I have 1, 2, 3 minus. The 3 plus and the 3 minus balance out, and this overall compound is neutral. That is our goal. So I have uncovered the ratio here. I just need to count. Okay? I have 1 aluminum ion right here, and then I have 3 hydroxide ions. Okay? To represent 3 hydroxide ions, remember, I need parentheses. I cannot write it like this. That does not mean I have 3 hydroxides. That means I have 3 H's and only 1 O. I want 3 H's and 3 O's. So this is wrong. Please don't do this. That's everyone's favorite mistake. So let's do another example. I am going to try to write the chemical formula for a compound containing ammonium and oxygen. Again, right away I notice this is a polyatomic ion because it has more than one element. It has nitrogen and hydrogen. So here's our polyatomic ion, and it's trying to bond with oxygen. Alright? So I know that my goal is to get a neutral compound. So I'm going to again write the charges in red. The charge of oxygen is 2 minus. So your first step is to figure out the charges of each. Okay? Your next step is to decide if they can bond in a 1-to-1 ratio and have the compound be neutral. So this is what I think in my brain. If I have 1 NH4 bonded to 1 oxygen, is that neutral? And my answer is no. A 1 plus does not balance out a 2 minus. I need 2 plus to balance out 2 minus. So remember, I have as many of each of these as I want. So I need to bring in another ammonium ion. Okay? And I should keep with my color coding here. there's 2 plus, I add them up. 1 plus and 1 plus is 2 plus. And then 2 minus. So see how that balances out? 2 pluses and 2 minuses? So this is a neutral compound. Okay, so I'm just drawing to visualize to get the actual compound, the ratio. Okay, so how many NH4s do I have? If you said 2, good job, I have 2 of them. Okay, so notice I have to write NH4, that's a compound. I told you never get rid of it. I have 2 of those, and then I have 1 oxygen. And again, don't be confused that I'm drawing this compound as one circle. It's too much to draw the single N and the 4 H's and it's just simpler to draw this way to visualize it, okay? Okay, one more example here. Lithium and phosphate. See if you can answer my questions, and please pause me to see if you're actually learning. Lithium and phosphate, which one is the polyatomic ion? If you said phosphate, you are correct. How did I know? Because there's more than one element. It has to be polyatomic. And what is your next step? If you said it was to determine the charge of lithium, good job. If you didn't know that, then you didn't take good enough notes, because I said that that's always your first step. So go ahead and write down. Your first step is to write down the charges. Then what do you do next? If you said that you ask yourself if they would bond in a 1-to-1 ratio and form a neutral compound, that is good. So go ahead and ask yourself, can I bond those two together and do they form a neutral compound? The answer, of course, is no. 1 plus does not balance out a 3 minus. Okay, that's not neutral. So go ahead and add whatever ions you need to get a neutral compound. Pause me and see what you would add. Okay, so if you added 2 more lithiums, you were correct. Yay. Okay, so see how if I add 2 more lithiums, I get 1, 2, 3 plus, and that balances out the 3 minus. So all of these bonded together are a compound. Okay, next, the last step is to write the chemical formula. How many of each ion do I have? Pause and try. Okay, if you said that you had 3 lithiums, 1, 2, 3, you are correct. And how many PO4s do I have? Just 1. Oops. And if I only have 1, I don't need parentheses. It's like writing 1x and then, I don't know, putting parentheses around it. It's still 1x. It doesn't matter. So I don't need parentheses. It's just PO4. Remember to put the positive ion, the cation first, and the anion second, always. Okay, one more example, and I'm actually not even going to show you how to do it, but what would be the chemical formula if magnesium and phosphate formed an ionic compound? Go ahead and see if you can figure it out. This is the hardest example. Pause me, please. And if you said Mg3 PO42, congratulations, you know your stuff. If you don't, please come in with questions. Alright, so after this lesson, you should be able to, using your notes, define polyatomic ion. You should be able to count atoms in a polyatomic ion, so you should have some examples down or questions written down for me. And then number 3, you should be able to use charges to form a neutral compound containing polyatomic ions. You better have some steps written down for number 3. What do you do first? What do you do second? What do you do? You saw me do 3 to 4 examples, so you should be able to pull out the steps using the vocabulary that you have. Those steps will be useful to you when we do more examples in class. Okay, it also helps you with questions. Instead of saying, oh, I don't know how to do this, how about something like, oh, I get stuck when you figure out the charge. Okay, that's easier for me to help you. So take the time, go back to the rest of the video, and write down those steps if you did not.